So welcome back students, and today we'll be looking on to calculus. This is basically introduction, okay, to calculus. So it also comes from a Latin language, and it comes from the Latin word calculus. So you see that it's a direct copy of it. Now it is from this word that we get the word calculator, and you know what a calculator does. So, but the literal meaning of the word calculus in Latin language is small pebble. And you would ask, sir, what is the relation between a small pebble and a calculator? Now, the relationship is in the ancient times, people used pebbles, small pebbles, to calculate. You would have heard about this thing. It is called an abacus. In the ancient times, very older times, people used to use this thing to calculate, and so that is how we get this is a very ancient type of calculator. Okay, so I think you get an idea of what calculus, the how the word comes. Okay, anyways, let us look into this. Why all this? Why do you study all this? I mean, why not? Anyways, you guys are jobless. But that is not the exact reason why I'm doing it. Now, there are many reasons, many applications of calculus, many applications. But it is. I'm not going to tell everything now. We'll just see on how you can find the area of a leaf. Now, if I'm asking you, students, how do you find the area of this leaf? The area covered by this leaf. How will you find it? To find the perimeter, it is easy. You can take a thread around it and open the thread and measure it in a scale. But how do you find the area of this leaf? Now, you know the area of a circle, pi r square. You know the area of a square, a side square. But this is neither a square nor a rectangle, nor a circle. You know the area of a triangle, half BH. But this is not a triangle also. So that is also not possible. So how do you find all the area of this? Anyways, before discussing about the area of a leaf, let us prove or find the area of a circle. And you would say, sir, I know the area of a circle. I know that it is pi r square. And I know that you do know that. But what I want to make you understand is, how do you know that? How do you know that the area of a circle is pi r square? So let us try, finding it using calculus. Okay, using the idea of calculus. So what I'm going to do is, I'm going to cut this circle into many pieces. Okay, so I'm going to cut the circle like this into different smaller and smaller pieces, into concentric circles like this. So if I carefully cut, and here I had to be a little more careful because it's very small, and if I keep carefully cutting them, I'm still cutting, and so I get different pieces. Now there's another way of cutting a circle, and that is like this. I could just cut it into 4 pieces, but there's a reason why I'm not doing that, but I'm cutting it like this into concentric circles. There's a reason why I'm doing that, and you will see the reason. Now what I'm going to do next is, I'm going to take any 3 pieces, one piece here, another piece, many pieces here. I'm going to take any 3 pieces and I'm going to open it like this. Okay, I'm going to open. Now you see that this is almost like a trapezium. There are 2 parallel lines, and then there is a thing like this here and here. Okay, I'll take the last one, the last piece here, third piece. So there's a line like this, and there is 2 parallel lines, and then there is a line like this, and you see, and this line like this comes because of our cutting, the way we cut. And I'm going to assume this as a rectangle. Okay, now I know that this is a trapezium, but I'm going to assume it, approximate it as a rectangle, and I'll tell you why I do that also. Now first of all, let us find the length of this line, I mean the length of this rectangle. Now the length of this rectangle, I mean, this is actually this thing, when I fold it, it becomes a circle. So what is this thing? Actually this is the whole circumference, right? When I'm cutting one piece and opening, that's when I get this piece. So actually this piece is the opening of a circle, I mean it's an open circle. So therefore this length of this rectangle is the perimeter of the circle, and the perimeter of a circle is called circumference. So I can call this 2 pi r. The length of this will be 2 pi r, whatever is the radius of this circle. Okay. And this small distance, this small tiny distance here, I will call it dr. Because it is a part of a radius, right? It is a part. See, it is the part of the bigger. See, it is a part of the bigger radius. This is the whole circle, and this much is the radius, and that dr is a small part of the big full radius, right? So we get a triangle. So we get a rectangle. Okay, we get a trapezium. I understand that we get a trapezium, which I'm approximating it to a rectangle with length 2 pi r and breadth dr. Now let me tell you why I'm approximating it to a rectangle. See, I have cut the circle like this, but if I had more sharper scissors, and if I could cut it into more and more smaller pieces, if I could cut one here and one here between this, and I could cut into many little very small pieces, then if I open them, it will be like this, small pieces, right? Now if you look at them from far, you see that it is almost a rectangle. Look at this piece. There's only a small protruding. It looks like a rectangle here. Each piece almost looks like a rectangle. If I can cut it to more smaller pieces, it will look like more of a rectangle. So do you understand? So this dr, how much small I make this dr, the more smaller I make this dr, the more better it becomes a rectangle. So my approximation, or my guess, or my assumption, or whatever you call it, my approximation is more and more correct as dr approaches 0. Do you get it? Okay, so now what I'm going to do is, so this circle has many pieces. This circle has many pieces. I'm going to open every piece, every piece that I cut. I'm going to open every piece that I cut, and I'm going to arrange them. So this is the innermost circle, the next circle, the next circle, the next circle. I'm opening each piece, so you get it, and I'm arranging them like this, side by side, side by side, side by side. Oof, it's too much. Okay. Now, and then I'm going to put a graph like this. I'm going to put an x-axis and y-axis. Okay, and I'm going to draw a line like this. And if I draw a line like this, what do you actually see? That every piece, when I open them, now it looks like what? It looks like a triangle. Do you get it? So if I can find the area of this triangle, and you know how to find the area of a triangle. So if I can find this area of this triangle, then I can find the area of that circle, the whole circle. I mean, are you getting it? Now, but you would say, sir, there is an issue. There is this space here, so it is not properly a triangle. And I would say, yes, you are right. But suppose I could make this dr more and more smaller. I told you that I would get more and more smaller lines. So I could get lines like this. Do you get it? Now it almost becomes a triangle. Now there is only very small pieces. But if I can make it more and more smaller pieces, then it'll almost look like a triangle. Do you get it? So how much I can make the dr small, it will look more and more like a triangle. Do you get it? So let me take that off, And what is the distance? So we need to find the area of the triangle, and we know it is half into breadth into height. So what is the height? What is this length? So this length is the outermost circle, right? The outermost circle. And what is the length of the circumference of the outermost circle? 2 pi r, and r is the radius of the whole circle, the outermost circle. Okay, because it is a circumference. What about this? What about this distance, the breadth? Let us look. This small thing is dr, right? We know that, and as dr gets smaller and smaller, we get better result, right? So as dr gets small, so what is dr? It is a small part of a radius, right? So when many drs are put like this, what does it come to? It adds up to become the radius. So the sum of all the drs are the radius, the r of the big outermost circle, right? So there's many inner circles, dr. We are adding them all up, and we get the radius, the total radius. Now let us calculate the area of our triangle. Half into b into h, exactly. B is r, h is 2 pi r. So half into r into 2 pi r. Then half and 2 I can cancel. So what will I get? Pi r square. Voila. So do you get it? So do you understand how I get the area of the circle, or how do I found the area of the circle? I found the area of the circle by finding the area of a triangle. Do you see the relation? Now, I was not trying to prove any relationship between circle and triangle. That was not my aim. My aim was to show you the beauty of calculus. Now, this is the idea of calculus. Okay, this is the idea of calculus. And now what I did, I took the dr and I made it approach to 0. That's what I did. So I can write it like this: limit dr goes to 0, or dr approaches 0 of dr. Limit dr approaches 0 dr. So you see how the limit, what we studied on limits, comes here also. Now I think you get you can think, how you can think of a way of how to find the area of this leaf. Draw these lines, on a graph. Find the area under this line. Then draw this. So then actually you don't have to find the whole area. If you can find the area of half this part of the leaf, then you can just multiply it into 2, because this is symmetrical. If you can find this, you can just multiply it into 2 and you get this area also. The whole area. Now that is called finding the area under a graph, and that you will actually study in class 12th. Not to find the area of the leaf. They won't teach you how to find the area of the leaf, but you will learn how to. You will learn the method. And if you remember this, if you can remember this till next year, you will learn exactly. You will learn exactly how you can do it. So we need two processes. In this finding the area of the circle, we use two processes, or two mathematical operations, and those are differentiation and integration. Okay. Now integration you will be studying only next year, and even differentiation you will be properly studying only next year. This year, in this class, in class 11th, you will be only learning a little about differentiation, the very basics about differentiation. Okay, so welcome to differentiation. From the next video, we'll come to see what differentiation is all about. Okay, so thanks for listening. Bye bye.